Hello everyone, I'm Ran from Zhejiang University. Today I will introduce the latest paper from our group, Nebula, a coordinating grammar of graphics. Multiple coordinated views are prevalent in model visualization system. Visualization across views update their content in response to users' interactions in other views. Users usually coordinate multiple views using interactive systems such as Tableau or textual languages such as Light. However, interactive systems only provide limited types of predefined templates to construct coordination. Although easy to use, these templates cannot fully satisfy users' requirement to coordinate views. By contrast, textual languages support fine-grained control of visual element and interaction configurations, which are expressive for various coordinations. But they also bring high learning and using overhead. The gap between the usability and the expressiveness of existing tools motivates us to develop Nebula, a grammar for rapid construction of flexible coordination. For two separated views, users could specify a natural language sentence to describe how to perform the desired coordination. Nebula will parse the sentence and coordinate the views correspondingly. The approach is threefold. First, to abstract the concept of coordination properly for both expressiveness and usability, we conducted an extensive survey. The survey involves 45 coordination-related papers from 1997 to 2020 in the visualization community, one business intelligence system Tableau, 5 tools that support multiple coordinated view visualization authoring, and 31 visual analytic systems that integrate rich coordination applications. The survey arrives at a corpus of 176 coordination techniques. Based on the corpus, we found that coordination is modeled as a data flow graph between views. For the example, when users brush the area chart above, the internal data of the chart changes. The coordination passes the data change to the area chart below and modifies its X scale, leading to the updating of the chart. Although the data flow graph is clear, we observed that users prefer to communicate coordination by demonstration, namely, describing how coordination is performed. Specifically, users usually do not use sentences like linking the selection of the chart above and the scale of the chart below to introduce coordination. They prefer to say the selection in the chart above is used to pan the chart below. Based on the observation and the traditional coordination model of data flow graph, we developed an intuitive demonstration-driven coordination framework. In the framework, coordination is formalized as a composition of interactions along with potential data transformations above the data flow graph. The interactions are divided into 7 categories according to the survey. The framework defines the interactions that are directly performed by users as a user-triggered interaction, and defines the virtual interactions in coordinated views that cause content updates as coordination-triggered interactions. The interactions are associated with the backing data and states of views for coordination data flow graph. Next, I will present several examples to elaborate the framework. The coordination select to select means that users select the data of interest, and the selected data will be highlighted in coordinated views. In comparison, select to filter means that the selected data will be filtered, and select to set will set the selected data as the dataset of the coordinated views. Select to append will append the selected data instead of overwriting the old for further exploration and comparison. Navigate to navigate maintains synchronicity with the view in which users pan and zoom. The coordination is commonly used in multifaceted analysis. Encode to encode keeps multiple views consistent in visual encoding. Reconfig to reconfig is used to synchronize the spatial arrangement between views, such as the attribute order. Based on our survey, we found that select is the most commonly used user-triggered interaction, while the set is dominant in coordination-triggered interaction. In addition, select to select and select to set are the top 2 popular interaction compositions. Other interactions and interaction compositions also have their specific scenarios. Grounded in the framework, we propose Nebula, a grammar to coordinate visualizations in a three-tuple: origin, destination, and data transformation. A Nebula specification describes how coordination is performed by composing the 7 categories of interaction and is written in natural language. For the example, the specification composes the interaction select of the 3 charts and describes the intersection of the selection of SketchPro 1 and 2 will be used to highlight the corresponding points of SketchPro 3. During the runtime, the specification is segmented. Then, tokens are labeled and the missing fields are completed. Based on the past specification, Nebula searches the corresponding views and data transformations to construct data flow graph of coordination. Specifically, each view and each data transformation is encapsulated with a reactive layer to locate interaction and the corresponding data or states. As such, each specification can be associated with the underlying data or states of views and data transformations. Finally, these located data and states are linked for data flow graph according to the parameter fields started with the $sign. In this example, $1 in the transformation corresponds to the first interaction in the origin, namely, select items in SketchPro 1. Therefore, Nebula links the backing data of the interaction to the parameter of the transformation intersect. Following the rule, the selection of the SketchPro 2 and the parameter of intersect, the selection of the SketchPro 3 and the output of intersect are linked. Therefore, the intersection of the selections of the SketchPro 1 and 2 could update the selection of the SketchPro 3. Nebula aims to balance expressiveness and usability to coordinate visualizations. Therefore, we evaluate Nebula from the 2 perspectives. To demonstrate the expressiveness of Nebula, we present a gallery of common and typical coordination examples in our survey. Moreover, we reproduce the real-world visual analytics systems SRVs to assess how multiple coordinations cooperate for complicated tasks. In this system, user selection will be highlighted in other views. In addition, the selection could be traced during panning and zooming in the map. Reconfiguring the attribute order helps users discover distribution patterns. To evaluate the usability, we conducted an analysis using the cognitive dimensions of notation framework to compare Nebula and the traditional coordination model of data flow graph. From the analysis, we found that the design of Nebula is inspired by user experience and is close to users' mental model. Such a high-level abstraction may be easier for users to adapt. In addition, the abstraction componentizes coordination, improving its consistency, visibility, and conciseness. Based on the analysis, we conclude that Nebula shows potential usability benefits to users. In summary, the contributions of the work include a demonstration-driven coordination framework based on the traditional data flow graph model, a coordination grammar Nebula for both expressiveness and usability, and the evaluation of Nebula in expressiveness and usability. In the future, we will improve Nebula and its related ecosystems by collecting real-world feedback and enriching coordination types. In addition, we plan to integrate Nebula and visualization authoring tools for efficient construction of multiple coordinated view visualization.